Okay, now let's look at this page 18 part D. Differentiation term by term for each of the following function with respect to x. Okay, so what happened here is they give us questions that you can simplify it into term by term. So for example, let's say the first one, we can expand it. So y equal to, you take this times this, 3x squared, 3x times minus 4 minus 12x, and then 1 times x you get x, and then 1 times minus 4 you get negative 4. Okay, then you get y equal to 3x squared minus 11x, and then minus 4. So we can simplify it to many terms which add and which plus or minus with each other, and then after that we can do dy dx, differentiation. So when you do differentiation, it is done by looking at each of the term by term. So we start from 3x squared, so the power 2 move in front, 2 times 3 is 6, so it becomes 6x, and then minus 11x, you differentiate. It's a special case, if you still remember, it will become 11. Differentiation of minus 4, it becomes 0. Okay, so the answer is 6x minus 11. Okay, so that means whenever you are able to multiply, so multiply first before you do differentiation. Likewise, if we are able to divide, we divide first before differentiation. Okay, so how to divide? We do like this, fx, we take 5x cubed divided by x, then we take 7x squared divided by x. So we divide first, then it becomes 5x squared plus 7x. So fx is still in front. Now we start doing differentiation, we write f prime x. Okay, so 5x squared, when you differentiate, we bring in front the power, 2 times 5, 10. 10x. The power 2, you minus 1, become power 1. 7x, special case, 7x you differentiate, you get 7. Okay, so that is the idea. If you can multiply, you multiply first before you differentiate. So if you can divide, you divide first before you differentiate. Now we look at C. We can multiply also. So we can multiply this with this with this. So where we have to know that the square root x there is x to the power of 1 over 2. So when you multiply this with this and with this, so what happened then is 3x. This is power 1. Power 1 and power half, when you multiply, you have to add up the power. So 1 plus half, it becomes 3 over 2. Plus 12x power half. Then we can start dy dx. Huh? So when you do dy dx, so basically what happened is the power 3 over 2 multiply with 3. So we get 9 over 2. Then the power, you minus 1, it become half. Okay, so the second term, the power half multiply with 12, we get 6. And then the power half, you minus 1, it becomes negative half. So if the question itself shows square root or surd, then normally we put our final answer in surd form also. So where power half is surd x, and then if it's negative half, we just bring it down and take surd x. So we leave our answer like this. Okay, now we look at part E. Differentiate each of the following function with respect to x by using the chain rule. So what is chain rule? Okay, so let's see. It is given down here. Chain rule. Y equal to fu. fu and u equal to gx. Okay, what is this? Okay, let's say example. I will put this as my example. So y equal to fu. How to understand? So you have to let everything in the bracket become u. Okay, let's take a look. Let u equal to 2x minus 1. Let u equal to 2x minus 1. We just take everything in the bracket become u, and then your y is u to the power of 5. This u to the power of 5 is fu. That means it's a function in terms of u basically. So that is the meaning of fu, is something in u. Okay, then now you have fu already. Y equal to fu. Y equal to fu. U equal to gx is what? This is the one. U equal to gx. This is your gx. Okay, so let me label it first. U equal to gx. This is your gx. This part, everything here is your gx. U equal to gx. So we have y equal to fu, u equal to gx. Basically, it means you have two equations. We have two equations. The first equation is y in terms of u. The second equation is u in terms of x. So two equations. Now you want to get dy dx, right? You want to get the differentiation, the first derivative, dy dx. So for the first equation, you differentiate it, you will get dy du. So which means when you differentiate this, you will get dy du, because right hand side is u, so that's why it's du. So when you differentiate it, you get f prime u. For the second equation, when you differentiate it, you will get du over dx. You see how we write the first derivative? Why this is dy du? Why this is du dx? Basically, the idea is whatever on the left, it will go up. Y is staying on the left, it goes up. dy. Whatever unknown on the right, it goes down. du. You see u on the right, it goes down. So same idea. Whatever on the left, it goes up. du. And whatever on the right, which is x, it goes down. dx. So when you differentiate, you have to you need to know what to write. Okay, so it's equal to g prime x. So that means you have two equations. The first equation you differentiate. The second equation you differentiate. After differentiate these two, then you have two derivatives. Then you have to multiply them. Then you will get dy dx. So let's see why when you multiply them you get dy dx. You take dy du, multiply with du dx, this one. Then you will get dy dx, because imagine the du you can cut away. Du cut with du, then no more already. So what left over is dy over dx. So that's why chain rule work in this way. You multiply the two derivatives that you get, and then you get dy dx. Okay, let's see an example here. So when you let u equal to everything in the bracket, you get y in terms of u. Now we differentiate it. So when you differentiate, remember how we write. Whatever on the left, it goes up, dy. Whatever unknown on the right, which is u, it goes down, du. Okay, then u power 5, right? When you differentiate, the power 5 go in front, multiply with u, so become 5u. The power 5 you minus 1, it becomes power 4. So dy du equal to 5u power 4. Okay, so this one, the second equation, u equal to 2x minus 1, we differentiate it. du dx. Why du dx? Because whatever on the left, it goes up, du. whatever unknown on the right, which is x, it goes down, dx. Okay, then we differentiate. Differentiation of 2x, special case, so it becomes 2. Differentiation of -1 becomes 0. Okay, so we have dy du and du dx. Now we use chain rule. Dy dx equal to dy du equal multiply with du dx. So when you multiply the two derivative, you better double check. Make sure the du cancel off and end up with dy dx, which is same with the left hand side. Must be balanced. Okay, if not, then you need to do, maybe you have to turn around or and so on. So it depends on situation. So dy du is 5u to the power of 4. Du dx is 2. Can I continue here? I get 10u to the power of 4. And at the end, dy dx, right hand side has to be x. So you replace the u with 2x minus 1. So which means this one, 2x minus 1, you put into u. Then you will get 10. 2x minus 1 power 4 and finish. So this is chain rule. Okay, chain rule. Okay. I show you an alternative method. This chain rule, you will feel like, oh, so many things to do. I need to substitute, then I need to differentiate this equation, then I need to differentiate another equation, then I need to multiply the two derivatives, then after that I need to resubstitute u with something in x. So it seems like so many things to do if you are using chain rule. Okay, so now let's see another method. Let's say the question never said chain rule. Then you can use a shortcut. There is a shortcut. But remember, we can use this shortcut if the question never said chain rule. If the question said chain rule, then you do like this. Okay, let's see the shortcut. Method 2. We use formula. If you have y equal to ax plus b to the power of n. So what form is this? It is a linear form with power. Linear form with power. Linear form means straight line. Straight line means mx plus c normally, but this is ax plus b. It's still the same idea. Still a straight line. So as long as x takes power 1, and then it's a straight line. So if a linear form takes power n, the formula is, okay, so first, the power n, move in front and multiply. And multiply with ax plus b. Multiply. The power n, you have to minus 1. So it seems like this is the normal step, Power move in front and multiply, then the power minus 1. So it seems like normal. But we have one extra thing. After doing all this, you need to differentiate the terms in the bracket one by one. Term by term, in other words. So it's like you have to differentiate ax. I know differentiate ax, it becomes a. So I have to write a in front. Okay, let's say before I close bracket, we have to see the b first. Differentiate b, it becomes 0. So that's why only a remain. Okay, so I put a reminder here. This is actually the differentiation of ax plus b. So differentiation of ax plus b, and you get the a. Okay, so this is the formula, and at the end, right, the a you can multiply with the n, so you get an ax plus b to the power of n minus 1. So this is formula method, and you will find these formula methods very fast in getting the answer. So let's take a look. If I have y equal to, I use back the same example. If you have y equal to 2x minus 1 to the power of 5. So I use the formula dy dx. So power 5 bring in front. Multiply with 2x minus 1. The power 5 become power 4. And then I still need to differentiate whatever in the bracket. I have 2x and minus 1. Differentiate 2x, I get 2. Differentiate minus 1, I get 0. So I have only 2 that remains after differentiation of the thing in the bracket. And then 5 times 2, I get 10. So now you compare with this and this, and you will realize this one, the working is just 2 steps only. Just 2 steps. This one, so many steps. Substitute, get 2 equations, differentiate 2 equations, then multiply, and then resubstitute. So many things to do, and this is very fast. Okay, so this is formula method. So if you don't see chain rule, then basically you can just go ahead with this. Okay, now let's see one more example. Okay, let's take a look on what to do if we have the 2x plus 7 at the bottom. So we still do the same, so the idea is whichever that takes power, right, you let it equal to u. So let u equal to 2x plus 7. Okay, maybe I put at the side. Let u equal to 2x plus 7. And then you substitute the u to the bottom, then we get y equal to 1 over u cubed. U equal to 2x plus 7 is the second equation. So now we have 2 equations. So y equal to u minus 3. I bring it up. Then I start differentiation, dy du. So where the minus 3, you bring it in front, u, and then this one minus 4. And then you bring it down, minus 3 over u to the power of 4. Okay, then we just stop like this first. On the other side, du over dx. So we differentiate 2x, it becomes 2. We differentiate 7, it becomes nothing. So now we use chain rule. dy dx. dy over dx equal to dy over du times du over dx. Okay, then dy over du is minus 3 over u power 4. Du over dx is 2. Then we get minus 6 over u power 4. Then we substitute the u. As you can see from here, the u is 2x plus 7. So we substitute 2x plus 7 and then power 4. So that is how we get dy dx. Okay, let's see method 2 one more time. I show you chain rule for twice already, so I show you method 2 one more time here. So if you are using method 2, right, y equal to 1 over 2x plus 7 power 3. So we need to bring it up. 2x plus 7 power negative 3. Negative 3, yeah? And then you can bring in front. You can bring in front the minus 3 and multiply. When you start differentiation, you can do so. dy dx. Minus 3 bring in front. 2x plus 7. So the power you minus 1 become minus 4. And then 2. And then you multiply 2 with minus 3, you get negative 6. Then you bring down the bracket because it takes negative power. Okay, so we get this. Okay,